So, very nice welcome to the Microservices lecture in winter term 2020-2021. And yeah, here we are. My name is Albert Sundorf. I do this in English because we are actually expecting about 50 students from University of Douala from Cameroon. Is there any Cameroon guy already here? Anybody from Douala? Please, sir, just give a chat message if you are there. That would be great. The point is, University of Douala has a large computer science department. It is actually large in the number of students, but very small in the number of professors. And we were in contact and they were asking for some help, especially concerning practical lectures. And after some negotiations, I said, okay, I'm going to Douala and give a course over there. And then came Corona, of course. So I could not travel to Corona anymore. And so we said, okay, these lectures are online anyhow. Why don't we just invite all the people back here to join our Zoom sessions? And then we could have a remote lecture this way. Unfortunately, University of Douala was closed till today. So the whole university was shut down and it was unclear whether it would open for winter terms. The Minister of Science was actually allowing to open universities and have lectures via Zoom or whatever just last week. And so University of Douala was not yet able to contact the students and to inform them about this course. And therefore, no one is going to show up today. We have scheduled a boarding lecture for Thursday for the Douala people. And after that, hopefully next Monday, we can really start. Therefore, today this lecture will be somewhat short because I have to give it twice for you guys and again on Thursday for the Douala people. And this is also the reason that I already do this in English, although only German students are here yet, because maybe we will just show this video to the Douala people. And then they can prepare in the same way than you did. So the good point here is today will not be the full 3 or 4 hours lecture, but we only have about one and a half hour. And I will just show you something about what is the content of the whole course and what we will do in this class. And then before we start with the actual work, we will switch to the next week. So, microservices, what's this all about? First, some formal things. This is a lab, after all. So you are in the 5th or 3rd term. So you have the new Studienordnung, whatever this is in English, regulations. And so you are required to do some labs. And the idea is that these labs give you practical experiences. And it's not a lecture, but something where you actually do practical work. And therefore, this class will actually be something which is very hands-on. And the idea is actually that I show you some development steps. For example, creating a web application with a login screen, for example. And I will just live hacking this app. And after 1 or 2 lines, I will stop. And you guys just repeat all the things that I do here and do it yourself too. And I will wait for you until you have done it. And when everybody in the chat says, I'm done, then I will show the next step, and then we repeat, and so on and so on. So we will collaborate or some parallel hack the application. And that's actually how we will spend the afternoon. And this takes a little bit more time than a lecture, and therefore it's actually 3 hours real time. Actually, we will do 3.5 hours probably, and some 15 minutes in the middle in a break in order to get some fresh coffee, in order to go on. The idea is that at the end of each lab session, you have actually achieved almost the same state than the things that I have shown to you. And actually, last year we were actually at the end of the session doing a round robin, going around all people, and they demonstrate what they have achieved. And when this is done directly in the lab session, we say, okay, that's all you need. Just show me your demonstration that there is a login screen that is working. But some of the people didn't manage to actually keep track of the progress in the lectures. And they said, okay, I need some extra time. And they were doing it at home. That is okay either. You can actually just watch this session and then said, I will program that later. The whole session is actually recorded and we will publish it on YouTube. So you will find a recording of actually just the screen that shows me and my slides, not the whole thing. So it's not you that we are recording, nor your chat is recorded. It is just the screen that shows me, which will be on YouTube afterwards. So you will not be exposed to other people, and that's we will not publish screens with your faces or your names on it. Unless I will actually name some of you. That will be on it. And it has my sound only. I think any sound, you should be able to actually unmute your microphone and actually speak. And for example, if you have a question, I encourage you to do so. I've learned that many students are too shy. Even now, most of the students do not show their camera image. Please shut on your camera. Switch on. Therefore, actually, I encourage you, you may use the chat if you have a question. And actually, Christoph is currently joining me, and he's actually supervising the super fancy video setup that we have created here. And a broken camera. Okay, come on. Corona is going on for more than half a year now. You should have a camera for doing FaceTime DC by now. Actually, you might also go into Zoom with your smartphone. Then you have a camera. That is also a good idea. So you can actually log in 2 times, once with your computer and once with your smartphone, and then you have actually a camera, and that would be great. Okay. So the idea of the whole thing is that you actually program something, and at the end you show your program, you demonstrate it. So then we do not need to go into the code details, and we do not need to, get this thing from GitHub and then compile it ourselves and start it, and do not know how to use it. And then there's a small problem that there is a password required and we do not have it. You just demonstrate the program to us on your computer, and then you get your grades or your assignment points. That's roughly the idea. So yeah, this is here. There will be about 15 assignments. I think we will, probably it's only 12 or 13 or 14, I'm not pretty sure. And we have good experiences with a progressive level of these assignments. So the first 5 assignments will be pretty easy, and you will get 10 points maximum per assignment. And then we have medium-sized exercises, which will give you 20 points per assignment. And at the end, there will 5 little bit larger jobs that will give you 40 points per assignment. And actually, some of these assignments will actually go a little bit into the spring breaks, the term breaks, and you will have to work after lectures for some 2 weeks or something like that on that. And if you get 200 points, you have passed the course. And if you get 350 points, you get a 1-0. That's the idea. Okay. If you come up with your code at the end of the term and say, oh, I've done it all, but I didn't have time to show you earlier, this looks suspicious. So then we will actually dig very deep into that code, and you have to explain it in very much detail, your architecture, which part of the code does what, and where this is certain functionality is located. So be prepared that we will go into your IDE, your programming environment, and that you have to show us all parts possible of your application. That should be no problem if you actually have done it yourself. If you just copy it from your neighbor, you will have trouble to explain it to us, and we will not give you points for that. If you cannot explain it, we assume it's not yours, and then we do not accept it. Be prepared, and we will be, well, less strict. If you actually do this during the lab sessions, then we can say, okay, yeah, we have seen, you have been there, and it's in time. You do not yet have time to copy it from your neighbor. Then a simple demonstration will probably suffice. But be prepared. We have a dice that we roll sometimes, and if it says, oh, well, let's have a deeper look into this one, you should be able to explain your code. Be prepared for that. Okay. The good thing is, if you try to demonstrate us something, and then the tutor or the teaching assistant says, oh no, it's no good, no, there's functionality missing, that's not a big thing. You can actually say, okay, yeah, sorry, I didn't do that, or there's a bug and it's breakdown. I will work on this some more days, and then I come back. So actually, you can do another round of work on this assignment. So, for example, you show it after the lab session, and we say, yeah, this is good for 5 points. It's only half the functionality that we expected. You can spend some more time, and at the beginning of the next lecture, you show it again, and you say, oh yeah, I have fixed this, and here are the missing parts, and then we will actually give you the other 5 points. So if we reject something and say, no, it's not yet good enough, you always have the opportunity to, well, yeah, fix it and then show it to us again and to gain the remaining points. That works pretty well in the last year, and so we hope that it is going to work again pretty well. Okay, but be prepared that actually all these things that we do during this term are building one upon each other. So if you just say, oh, I have no time this week, I'm skipping this assignment, it's not going to work. You're will not be able to do the third assignment if you did not do the second one. So then the week later, where you have time again, you will actually revisit assignment 2, do that one, and finally you can actually do the current assignment. So be prepared that you have to do it all. Otherwise, you won't get past the final exam or to get enough points overall. There's no way to skip something. And that's actually the reason that we said, okay, it is reasonable to say, okay, here's something not yet wrong. It's not working. It's a buggy. I have no idea what. Take your time, fix it, and then show it to us again. Then you get your points, and then you can build upon it the next week. Okay. We will see how this works with Zoom. Actually, we didn't do this before, but actually we will not do it today because we are not yet starting with lab sessions. But next week we'll do it, and there at the end of the lecture there will be breakout rooms. That is something that Zoom offers. There will be some 10 rooms or something like that. And there will be tutors or teaching assistants and myself and Christoph and all my people that are sitting in these rooms. And then you go into one of these rooms one by one. And or we put you in rooms and the tutors are going to visit you. And then you can actually, well, prepare your demonstration. While you are waiting, you might go on and do some hacking and enhancing it. And at some point in time, you will see your tutor in your breakout room, which is actually private to the two of you. So no one else can actually see what's going on. And then you show what you have done and you get your points and or your improvement suggestions, and then you go on. So that's pretty much the idea. We never did this before, and I have no idea whether this is going to work. But Corona teaches us new things. Okay, let's see. Hey, we have decided to organize our lecture a little bit with Discord. And there is this link over here. And hopefully, let me see this. No, well, yeah, okay. I would like to go to our so the entry to this okay, and I'm offline. No, please. I hate it. How can I be offline? I think it says I cannot go to either room. I'm in. No, I'm off. I hate it. So what I wanted to show to you is that you can go to our website, of our department, and there you might find the entry points to these lectures. I actually wanted to have these slides over here that you can access them. Christoph, Leonard, is there somebody? Clemens, or I need help. Can you just show the let's say the website of our group and where we can actually do the entry to here, and if there is a link to the Discord and if there is a link to these lectures, to the slides of this lecture. Yeah, could you switch on your screen? Can you do it? And share it with the others. Yeah. I can see it. Anybody else? Please, it does not suffice to wave your hands because we cannot see your hands anymore. Put it in the chat. You can say. Okay. Okay, you guys see me again? You may actually put a focus on my Zoom thing so that everybody sees. Great. Okay, this is strange. I know it's collected to either room, but it's still not working. It's perhaps the browser after all. Yeah. Yeah, stay tuned. You probably have to show Discord to the guys. I'll try to make it myself, but who knows? If it's not able to connect. It still has at least something. So this is the Discord to our. Yeah. I'm so old. Let's do it this way. No, so that way. This is the Discord. Can you see my mouse? Yeah, cool. Um, you join this group. The link is on the web page, and there will be a lot of chat channels where you can actually reach your teaching assistants that help you with questions on programming and these kinds of stuff. And there is already a pretty important channel here, which is the boarding, which gives a pretty long list of things that are your first assignment. Well, actually, it's assignment number 0 because you won't get points for it already. And the thing is, we want that you prepare your computer to actually do this lab work. So in the next Zoom session on next Monday, you're having prepared your computer with all the stuff that is down here. You need good internet connection. You have it probably. This is probably a problem for some of the Douala people. Then you need to go to some internet cafe, I have no idea, or to the university itself and get fast, reliable internet. You need to run Zoom. You need to run WebStorm. You probably need to run Docker. I'll explain what this one is. Docker is later in the sessions. You must have a webcam. I'm not going to do work with you in a breakout session where we will actually do a demonstration of your assignment. You have no camera, you do not get points. Full stop. I actually want to discuss with you. This is an interactive thing here. It's not just a video up in the internet. If you do not have a webcam and cannot speak to you, cannot see your face, I'm not going to give you any points. Full stop. You need a webcam. You need some headset or microphone that we can actually talk to each other. It's pretty important. We want to do screen sharing in addition, and I want your face. I am going to use IntelliJ WebStorm for this. You can have a free license as a student usually. We are still looking whether this also is true for the people from Douala, but it should work. And I use WebStorm not because it's the best thing ever, but for some 3 years ago, I was switching from Eclipse to IntelliJ. And so I'm not ready to switch again to Visual Studio Code. And IntelliJ is pretty good for Java and for TypeScript. And so this is the one of my choice. All the other people in the world, Visual Studio Code is the most favorite thing to program TypeScript. If this fits for you, it's okay for me. However, several things that I'll show you what you can do with your IDE. I have no idea how this is going to work in Visual Studio Code. So some refactoring things and these kinds of stuff will work only if you use WebStorm. If you're familiar with Visual Studio Code and you already know all the tricks, stick with this. There's no reason to switch to WebStorm if you're already happy with Visual Studio Code. And these are always some other thing. It's just that I use it, and for newbies, I recommend it. Then you can actually profit from these things I'll show you the most. We will run this on GitHub. Well, actually, you need some kind of Git client that allows you to actually upload and download your solution to GitHub. I use Gitkraken for this. So again, if you have no other preferences, this is Gitkraken, and this actually for this thing, and there is something that has changed, or the workspace XML. And quite a lot of it. I have no idea why. Okay. Oh, that's probably, it shouldn't be in the thing here. I state these changes. You can see that? Yeah. I want to be back in your life. Hi. Um, no idea. And no ever do something like no idea in your commit message. And okay, we will have a GitHub repository for you, and actually you get that via GitHub. You need an account on GitHub to do that. So you log in there, give your name, your email address, and promise them to give them your firstborn child, and then they give you an account. And there are a lot of spam emails will reach you from that on. Okay, I'm looking for the link to slides of the lecture. This is cool. I wanted to show you that one here. This is GitHub Classroom. If you have, so who knows GitHub, by the way? Who has an account on GitHub? Almost everybody. Cool. So that's not too hard. Who has used GitHub Classroom before? We actually use it in programming methodologies a lot. Okay, we are fine. We do that. And that is things that you need to do. You will need Node.js. I'll explain why in my lecture, but basically it's a TypeScript interpreter machine that runs on server side. Usually TypeScript is executed in your browser, but if you want to have it also in your server, then you need to install Node.js. That is the thing that you use, fine. You need to register for this lecture via this form here. May you put your name, your email address, your student ID, Matrikelnummer. Oh, the students in Douala won't know what this is. And your university. And actually, this is necessary. From this, we will generate an Excel sheet, a spreadsheet, with the list of all the students, and then the columns for all the assignments they have already done, and at the end, sum up all your points and give you your grade. If you are not in that table, you are not going to get a grade. That's it. Very easy thing. So please put in your name here in order to enable us to grade you and give you points. There's links to the slides of this lecture. Hey, if you click on that, please could you do that? And then you should actually get those Google Slides on your thing. The good point about this one is, oh yeah, there are some people. Cool. 4 people did manage to join here. The good point here is that when you open this in your browser directly, and some of the slides may have links within them, then you can actually click on that link and or copy paste from this and follow these things. I will actually also do some example code that I would say, okay, people, don't try to type all these parameters in here. Copy paste into the slide during lectures. And if you should actually see such changes directly. Let's test this. Can you see this? Can you see that? Hey, cool. And then you can copy paste the code examples from there and put it into your environment, and then you will get around some tricky things that we need to do. That's the other thing that we wanted. Okay, cool. Content. So that was all the preliminary. No, we are not done with the Discord yet. GitHub Classroom, yeah. Once you have downloaded the GitHub Classroom project, it's pretty naked, it's empty at all. What you actually have to do is this here. npx is, and you do it on a command line. Who knows what a command line is, or a terminal? Yay, cool. Oh, let's just do it. No, I'll do it next week. And in order to have this actually will set up a TypeScript project for the programming of a single page web application for you. We will use React in these lectures. Last year we were using Angular, and well, I still have quite a discussion with Sebastian Kopay going on, who says, oh no, they need to know how it's working in detail and no shortcuts and do it the hard way. Otherwise, they will not learn how to do it. And well, Angular is probably the most professional web framework at these days. React is actually, well, closing up to Angular, but it does a lot of shortcuts. So it's much easier to learn or to start with, at the danger that you do not get the basic things, the core concepts, because they are hidden from you. Well, we just said, okay, if we cannot come to a conclusion, what is the better approach? Let's try both and see which students are better, the of last year or the of this year. So this is an experiment from our side of view that we have no idea which of these frameworks is working better, and so we just will try it on you, and we will see at the end of the term. If you run this, npx is actually a program that should be installed together with Node.js, and that should actually do these things for you. You get a whole new thing, and actually the name that you put here, webshop, is the name of a directory where you can actually go into it, and then you can do npm start. Npm is the Node package manager, is yet another program that comes with Node.js. And that is actually a command line tool for doing compiling and these kinds of stuff. Who knows Gradle? Gradle, anybody? So npm is pretty much the same thing for TypeScript or for JavaScript things, what Gradle does for Java people. Okay. Okay, there's a question here from today, actually, asking why WebStorm and why not IntelliJ. It's just the same thing. So WebStorm is another branding. It comes from IntelliJ, and it has pre-installed the packages that you use for web development, for TypeScript and for JavaScript development. If you download IntelliJ IDEA directly, you get it with the Java packages. If you have it with the Java packages, you can easily install the TypeScript and web packages in addition, and then you are fine. And then this is exactly the same tool than the WebStorm thing. WebStorm is just pre-bundled installation of IntelliJ that fits for the needs of this course perfectly. If you have IntelliJ and you just say, oh, I would like to stick with this and just install the additional bundles, no problem, we can do that. It's just the same thing. Okay. Yeah, and already Sebastian has declared it. So, and actually, I want you to be here at least in the next session. Well, actually, we will do one more, and I will add it at the end of this lecture. So back to the lecture. Content. What are we actually going to do? We will build a single-page web application. Whatever this is, I'll explain. With TypeScript. Whatever this is, I will explain. Based on React, what I explained to you. We will use awesome cascading style sheets. I'm not really sure about that, actually, but come up. If you want something professional, you need something like that. So we will probably use this from semantic UI. Or we will use these things from Google, material design, I will see. We have used semantic UI last year. It was not bad. Yeah, let's do it again. Then we will program backend services, web servers, after all, with Node.js in TypeScript. And we will do a database mapping. So to have persistency, we will do this with Postgres again this year. And not because Postgres is a relational database, which comes for free. And we have chosen that one because we will deploy our services in the cloud on a platform as a service cloud thing, which is Heroku. On Heroku, every of you can have 4 virtual machines running a service that you programmed. And this comes for free, and we will actually use this. Okay, then there will be, and Heroku actually says, okay, we can have also access to a database to store data persistently, but it's only Postgres. If you want something more modern, like MongoDB, you need to pay for it. And therefore we said, okay, to have this course free of charge for our students, we use only open source software and we will use it with Postgres. It's not too bad. And we will do something which is called microservices architectures, whatever this is. And now I will do something just to get every one of you on the same page. So now comes some pretty boring background about web applications. So in the good old times in the 80s, when the internet shows up, we have had web pages with static content. And it basically means that, okay, this kind of diagram. Here, this top box which says Alice browser tab is actually, well, a browser on some computer running. And actually, I will use another tab down here, which is another, well, virtual machine that is actually running a server, a web server. And this has come on. Down there, go away. It has something like a disk persistent memory space attached to it, where actually the files are located. And here it is actually that at some point in time, Alice opens her browser and surfs to www.x.com hello somewhere, which actually results in her browser tab or her virtual machine or her computer, whatever, to do a HTTP request, a GET request, with these URL shown up here, which actually should have a HTTP in front of it, but come on. Then the magic internet is going to resolve this first part of your URL into the name of a certain computer, routes your request to that computer, so it results in reaching to this computer, then a certain port on that computer, which is probably port 80 or 8000, I'm not sure. It's probably 80, which is the standard port for HTTP. And there the request is handled by a web server. And actually a very simple web server that just serves static content, it's 3 lines of code. It's not a big thing. And actually what this thing does just takes the ending, the tail part of your URL after getting off of the computer name and says, okay, you want to see /hello. I go down to my disk, and you don't see it because this thing is in is there. Go to a certain directory on my disk, find this hello something like there, or start HTML like there in a certain directory, grab you the content of that file and send it back. And this is not, here we are. So this is hello, and it searches for hello.html and gives you the content of that file, which is the description of a page in HTML, hypertext markup language. It has these tags in pointed brackets is the name, spitze Klammern, are pointed brackets, and it has an opening tag, which is the HTML tag here, and pointed bracket open / HTML pointed bracket closed, that's the closing tag, and in between these are other pairs of tags. Body, H1 is highlighted 1. It's actually a Überschrift, header line 1. And this is a formatting description. It says, oh, use a large font and make it bold. And then your browser is going to read this description and render this page to you, and then shows you a nice picture of this. So what you actually finally get is a hello world. Hey, cool. But the important point, and which is actually the stressful thing in this microservice lecture, is there are multiple computers involved in this. And you need to communicate between these computers and to get these things running and working together. And having multiple computers results in a, well, client-server system or distributed system, Verteiltes-System. And so these are pretty tricky to program. And we will run into quite some difficult problems that requires software engineering to come up with quite a different style of programming in order to tackle all these problems that you get when you have a distributed system. And that's actually the core content of this class, after all. So this is a static page. So actually, it's just you get a file from another computer, it is sent to you, and then you show the content of that file. That's pretty boring. And then in the 90s, we were saying, oh, we would like to have something more interesting, something more personal, more dynamic content in our pages. And so the next thing were server-side rendered HTML pages. And the point here is that Alice has now a login with her login name, and a real name or a password, whatever. She presses OK. So the content of this form here, of these two fields, is then sent to the server. And the most simple way to do this as a parameter in the URL. So then there is this login URL, then there comes a question mark, and then the name of the parameter, and the actual value of the parameter, ampersand, next parameter name, next value, with an equal sign in between. So this is the encoding that we were using in the 90s in order to send data from the client browser to the server. So the server says, okay, you want login, great, and gets to the disk, gets the HTML file that describes this. So now the HTML file has special markers in it. It's actually a so-called template. And a usual template is that you use double curly braces. You see here on the name, and I hate this thing, go away. So, but actually Brandon is going to stop my session. So that's not cool. You see the double curly braces behind the hello? Who sees this? Hey, you're still there, cool. and there's name in that, and this actually says, please replace these double curly braces with the content, the string content of the name variable. That's what's actually happening here. So what the server is going to do is it loads this description of the HTML page, searches for these curly braces, replaces them with their current values, and then have an HTML page which has dynamic content, if you want so, and sends this to your browser. And then the browser of Alice will show Hello Alice and not Hello World anymore. Hey, you see these huge, these enormous progress that we did in the 90s by actually saying, okay, there's content from the user and it's shown on my web page. It's so cool. And actually from this to Facebook, it was just a small step that people could send any kind of data and pictures and whatever, and will actually create their own web pages with the help of this. And that's basically the thing here. And the actual content is actually then there in this databases after all. So these days we do single page web applications. And which is actually the point that this, replacing these curly braces, these template expressions with content is done at the client side and no longer at the server side. That's the full thing. That's all that we do. So if you go in a single page application, we have again this login page here, Alice 42 with name Alice. We click OK, and now we do a HTTP post for whatever reasons. This is somehow a matter of taste. Well, actually, we just send here, we use another encoding for the parameters. So we want a new user with username Alice42 and with clear name Alice. And then we actually call some operation on the server side, which is say, hey, we would like to have a login for Alice with Alice42. And then we have a database which now just no longer contain the static HTML page or the HTML templates, but just the data. So we have a table with the users, for users with username and a login name and clear name for the user. So next what we do is we want this Hello Alice page. We do something which is called routing on the browser side. And said, I would like to switch to the welcome page. And then we do a get and say, hey, we want a welcome for Alice42. And then we do a get name on the database to retrieve the clear name for Alice42. Then what we get back here is something that is called JSON, and it's slightly simplified in here. So we actually send a textual description of our data, and we do it with JSON, which is Java serial object notation. Serializable object notation? No. Does anybody know what JSON stands for? Please put it in the chat, please.
JavaScript object
Hey,
notation.
Christoph knows it. It's JavaScript object notation. Okay, thank you. And there is also, thank you for the comment in my chat. Cool. So, what we actually get as a result from this request here is not a full HTML page, but just, hey, the clear text name of Alice. And then we do something which is called here render. We have the HTML page already on the template with these curly braces already within the browser. And we just do this replacement of the curly braces with this Alice, and then we can actually show it. And the point is that all the time we are still on the same page here. So the headline is not going to change. So in a default, good old school web application, you would do a GET request, or any request from the client to the server would actually render a brand new page for you. Then you have a new page. After each click that you did, you get a new page. And this is, for something, it's pretty slow. And if you have some content of some variables on your current page, and then you switch to a new page, all that content is lost. So anything like the user login name and this name needs to be from here to here, needs to go through the server and then send back to you. And that's pretty tedious after some time and cumbersome, and you don't want it. And if you have large content like a slide here, you do not want actually to and you are editing on the slide directly, you do not really want to, well, send all these data back and forth between client and service all the time, but you want actually to do this in a smaller amount of data that you send around, only send the changes around. That's basically the point that leads to single page web applications. They are much more dynamic. And actually, a single page web application is pretty much the same like a Java program on your desktop. It has pretty much the same abilities. You can pretty much do the same things. And it's actually a program that is fully on its own with a user face sitting on your computer. Still, web applications are different from desktop programs. Because they are still usually, well, they don't have access to a disk. They cannot easily persist data in a reliable way. You have in your browser local storage, which is another kind of database. But if your user presses F5, clear cookies and these kinds of stuff, you will easily lose all the content of your local storage. So it's a pretty temporary thing, and therefore we shall not rely on this for data that you would like to have for longer than an hour. And therefore, that's a point where single-page web applications will actually send the data to some server, and the server is actually storing it persistently. And when you reopen it or revisit this thing some 2 days later, then you go again to the server, retrieve your data, continue working on your data, send back the new data to the server, and this is how this works. And this is basically the thing that we need to get hands-on and that you need to learn how to do this. So what is a microservices all about? So this is still single-page web applications, and I'm now ready to explain what is a microservice, which is actually when your web server grows too much, if it becomes too big in whatever dimension, then you need to split it up into multiple web servers. And those smaller web servers, that is what we usually call a microservice. So the thing is, if you have a microservice architecture, you are not talking to a single web server anymore, but to a bunch of those web servers. There's quite some reasons for doing so, and we will discuss this on the next slide. First, I will show what this means for you. So here's Alice again, and she's now in the web shop. She wants red shoes, says this is my name, and this is the delivery address I would like to have, and sends OK. Then this data is combined into a post, is sent to a shop server, www.shop.com, where Node.js is running. So this is just to clarify how this is handled. There it will trigger the operation buy for Alice red shoes, send them to $1.01. This is then stored into the database that belongs to this computer here. And there's basically a record says, oh, the order is number 23, for customer Alice, the product is red shoes. So usually this is a little bit more complex because one order is multiple items and all kinds of things. But we just say one order, one item, and our shoes is just one size fits all, and it's pretty clear which one Alice is going to want. And then this shopping thing is done. And now, what the next thing that needs to be done is, well, we have to send these shoes out to Alice. And for technical reasons, we have decided that there is another server that runs in Harleshausen or Hershausen, where Amazon has its big outlet or stores. And we wanted a server which is close to that location and that is used by the picking people that are working at this large storage building. A picker is the guy that, or woman or man is, I think it's both, guy, I have no idea, actually run through the store, rich on the shelves, has on a tablet, I need to send red shoes to Alice, Wonderland 1. And then he knows, I will find the red shoes in row 4, shelf number 5, board number 3. And then he goes there, grabs the package, puts the address on it, puts a postmark on it, and then puts it in the outbox of his cart. And then he does the next job. So this is the picking process. And so the picker actually uses, again, a browser-based device perhaps, and says, okay, please, can you say me what should I pick next? And then we have this deliver command coming from the shop to the store. And the store says, okay, I'm creating a pick task, put it into my database, and send it to Power Picker, because he's requesting for a new task. And so Power Picker gets on his device, on his phone or web page saying, there needs to be, you look for red shoes for customer Alice, Wonderland 1, and actually it should tell him where to find those. You should have another line here. I'm not done with that. Okay. So, and what you see is that we have now 4 computers that participate in this whole scenario, which is actually Alice's computer, where the browser is running, and to be more precisely, actually on Alice's computer, there are more than one program running. And actually, from the JavaScript perspective, every tab in your browser runs its own JavaScript virtual machine. So, and from the perspective of the JavaScript program that is executed, these tab provides me with main memory and program code and execution mechanisms. So I get CPU, all the things of a virtual machine. So for the tab, for the program that is executed in one of these tabs, it actually says, okay, this is my machine. And I will actually refer to this as a machine, a virtual machine, a computer where this program is actually running already, that is switched on and executing a program. And the main parts that I'm interested in is main memory, the program code, the program counter, where am I, and connections to other computers. And perhaps the disk. Okay, cool. So we have for Alice Browser tab, we have one server running on some computer, and that deals with all these ordering things. And we have another computer that organizes all the picking and sending. And we have people running browsers. There might be even more here, 100 people buying things, 10 people picking the things. And they all have computers, virtual machines, things on, and all this is happening in parallel. And that's the point here. And there is communication between the servers, which you as a customer usually don't see, and that in the early days we didn't have. There we have had communication between the browser and one server, and we were done. And this turned out to be too restricted, and therefore microservices proposed to have multiple servers and have communication between those servers in addition to the communication with the browsers. And that's the thing, what microservice architecture is actually about. And actually, a microservice is one of these web servers here. So that's actually a microservice. And this is a microservice. And the browsers are usually not considered microservices. There was quite a discussion going on last year where I did consider these as microservices too, but that's not true. I have learned about that. So why do we do that? So why would we split a web server into multiple servers? And there is a bunch of reasons for do that. And actually the problem is scaling. And you can scale in different directions. And the first scaling that you use, if your name is Amazon or Google, then you get 1 million requests per second or 10 million requests per second. And a single computer is simply not able to serve all these requests. And so the simple thing that you first do is set up multiple programs, multiple computers that all run the same web server. So actually Google has multiple computers, each has its own database, and each of these databases has all the pages and the searching for pages in it. And just multiple copies of that, some 100,000 or something, I have no idea. And then the incoming requests are just sent to all these different computers round robin. And all these computers have exactly the same functionalities, the same data in them, and it's just replicating the service. And you do this to be able to handle more requests per second. Everybody on my page? Did you get it? So that is the x-axis scaling. It's just horizontal duplication. So this picture here is from Chris Richardson, the microservice pattern book. And hopefully I'm online by now. And I can show you that. Actually, it's a link here. Come on. I can click on that. The microservice pattern book. And actually, you can get it, you can download it from the web. It's for free. And it's the great book, which is the content of this lecture or this course is actually based on. The problem with this book is I already read the first half of it. I'm still in the process of reading it, so I will read a new chapter and then we will have a lecture on the new stuff during the term. Will be interesting. And if you read the chapter before me, you are ahead of my knowledge, and that will be very good, beneficial for our course. We can have a discussion on the topics. Did you see this the same thing than I do? Or do you think, no, Chris was saying it differently, and Albert, you are doing it wrong? And then we could learn so much more. So please read this book. It's really cool. And it's only some 700 pages or something. Okay, and it's for free. It's great. I actually have it too. Okay, presentation. Richardson pretty much says, okay, there are these 3 dimensions of scaling. Once you have done the scaling in x-axis, you say, okay, yeah, but I'm Google. I have millions and millions and tons of pages that I actually have to serve. I cannot put all these pages, the content for all these pages on a single computer. It's not possible. No way. I can't do that. And then what you do is you do partitioning. You say, okay, we set up 2 different kinds of databases or different computers. And let's say we do one database and computer where we serve all requests from A to M. So we have keywords we are searching for, and if the first letter of this keyword is an A, B, C, D, E until M, we go to the left computers, and if it's N to Z, we go to the right computers. And so the load of each, the amount of data one of those computers has to handle has been dropped to a half. Hey, cool. You can partition also in a different way for other reasons. So what you can do is have a computer for Germany and have one for the USA, or one for Europe and one for the USA. And then you have, well, actually all the data probably in there, or you have pages with German content. And that, okay, all the German pages are on that one. And if you have come with a German keyword, I send you to that page, to that computer, and he is going to help you. That is thing that you can actually do. And this thing that you say, I split my data according to some criterion, and then put the data in chunks on different computers, and then this is my application. That is called partitioning, and this is Z-axis scaling. And that's still a pretty simple thing. And well, actually, each of these programs is still the full code that has all the functionality. What you have done is now you have split the data and said, okay, you are working only on these lower first half of the names, and you are working on the second half of the names. You get it? Okay. And now there comes microservices. When you say, okay, this server for Amazon, it's so much code. It's millions and millions lines of code. It's almost as complex as Microsoft Windows or Linux or whatever. We cannot handle that anymore. There are so many bugs. It crashes all the time. New releases are awfully complicated. And we would actually like to come up with something smaller, more handleable. And then what you do is you take your big monolithic application, your one big block, and cut it by functionality. You say all the shopping is going to this computer, all the picking stuff is going to the other computer. And then we have two different programs, and we have different programming teams that are taking care of these two different programs, developer teams. And therefore, we can actually split the program size to the half. We can have more parts, 10 parts, 15 parts, 100 parts. And then we have a lot of small programs, and each of these is developed by a different team and evolved by a different team. And that is much easier to handle from a software engineering perspective. So what we actually do if we go from monolithic to microservices is we do software engineering. We said, oh, the programming complexity is killing us, and we would like to reduce it by splitting one big program into multiple small programs. And the problem that we get by this is, so now we have multiple programs on different computers that are collaborating. And this causes a lot of stress. And how to achieve that is actually a complicated thing, but there are, patterns in this microservice pattern book, which actually help you on that. And so this is what you actually should learn during these lectures. The patterns that show you how to organize the collaboration of multiple services and browsers, and how to do this y-axis scaling after all. Okay. My camera picture is black. Christoph is looking for it. It's probably out of power. A timeout or something. Hey, yeah, here I'm back again. Yeah, cool. There it comes. Here we are. Okay, cool. Cool. So, what are the goals? At the end of this course, every of you will be able to develop a complex web application that is supporting complex workflows. So a workflow is actually this scenario that we have here, where we have multiple computers that collaborate and they do something in order to achieve something which is bigger. So all this here is actually something which is called a workflow. Well, actually, a workflow is usually a program that says how multiple computers should collaborate. But it's also one scenario where you can actually walk through a certain example. And we would like to have these workflows that should be supported by our distributed web applications using multiple microservices. So what we actually would like to learn how to organize workflows that involve multiple services. That's it. That's the basic thing. And this will actually enable us to use modern agile software development techniques on microservices. And that's the point where we would like to go to. And from my perspective is this step from a monolithic application to a distributed application with multiple microservices that collaborate to achieve a certain workflow, to support a certain workflow. That's the thing that is going to change our society dramatically in the next 10 years. Well, actually, I would suppose that who knows what SAP is? SAP? SAP is the standard application, at least in Germany and Europe, for running your administration and business. So our whole university is actually running on SAP. So his boss is based on SAP. Is it? Is it not? I think it is. Who knows? The problem with SAP is they have this monolithic approach. So they have an enterprise-wide data model that covers all the aspects and put it on a single application. And this is not working. It's actually killing all these big enterprises that have huge, tremendous problems in order to change the software that they have bought some 10 years ago and to introduce something that I would call a digital business that is actually not possible or very hard to do on top of SAP to introduce something like a digital business. So you could not have started Uber with SAP. No way. That would not have been possible, I believe. And or Airbnb or all these modern things that we have these days. And so this is the architecture of the new world that we are going to learn in this course or in this class. So that's it. And what I wanted you to do is I need to, once you have add this script here, this line to the Discord, after you have done that one, no, it's already there. Okay, fine. Nothing to be done. It's all cool. I didn't see this. So this is actually installing your React application. If you have done that, let me see. Then you should have something like view, appearance, presentation mode, Alt-1. Yeah, oh, it looks good. I need the terminal, and I always forget it. Terminal, Alt F12, alternate F12. Here we are. Oh, it's running after all. Let's stop it. Go away. Can you see that? Almost, yeah. I think I need to go away. So here I'm in this web shop, and then you can do an npm start. And it will start your web application, and it should open up your browser, hopefully. Yeah. It starts my browser with localhost 3000, and then I have the starting page, example page, that belongs to my application. Actually, to show that this is really working, what we can do is go here, view, appearance, exit full screen. I tested this before, so I can actually go here, and then we can, well, what's that? Go away, please. Installation, what's going on? We could go for, here, and just show that if I change something here, hello Alice, it should automatically be updated on your web page. So this is pretty much the setting that we are going to work with in the next 2 weeks in order to build our first application. And did I prepare? No, I did not. An overview of what this application is going to do. This will be next lectures. So as an example, we will actually build, let me see, perhaps I can show you that. No, it's not good. This is an event storming, sorry. We will actually do this web shop example with the additional storage where we actually do this picking and sending out of things. And that's pretty much the thing that we would like to have. And there will be quite a number of user interfaces and people involved, even some more than we have had the last year, because we know so much better how to build it, and it will be much easier these days. Okay, so that basically is it for this week. Please prepare your computer to be ready. It might be a good idea to have 2 screens on your computer. One where you actually could work on, and one where you could see the lecture. That would be helpful, or you will have to arrange if you have only a thin screen, but if you have a second screen, that might be a good idea. Okay, so I hope this seems to be interesting to you, and I hope to see many people of you. Node.js 14 is the new, still using 12. I have no idea which one I use. Let me check. Sebastian? Yeah, okay. How do I do that? No, I don't think so. As we go with Heroku, we don't need Docker. Okay. Yeah. So whoever always wanted to do it with Docker, it actually helps you. You might have to install Postgres on your computer, and that's much easier if you have Docker already installed. But as you like. So it's both possible. Yeah. Okay. So then I would like to thank you for your for listening, for your attention, and hope to see many of you next Monday with your computer ready, doing all this stuff. Bye. So, jetzt bin ich schon mal nicht mehr zu sehen, aber I'm still on air, aren't I?
Aufnahme. Die Aufnahme.